In our previous video, we discussed about different types of attributes. There are mainly 5 different kinds of attributes that we want to separate it and then discuss individually. 3 of those including the composite attribute, multi-value attribute, and complex attribute. Because they have some similarities, so I want to emphasize on these attributes one more time as the beginning of this video. Another 2 types of the attributes we discussed, including null attribute that can have a meaning of not applicable or unknown to represent the null information in database. Another one is the derived attribute indicating the value can be calculated from some other stored information. And therefore, null as well as the derived attribute has less confusion. But composite attribute, multi-value attribute, and complex attribute, they are sometimes very confusable. So for a composite attribute, as we discussed earlier, it is an attribute that can be further divided into smaller subparts. So for example, address. So they can be further divided into street, city, state, zip code. A name, person's name, can have first name, middle name, and last name. Another one is a phone number as another example. It can separate into area code plus the rest of the numbers. So those are the attributes can be further divided, and that's what we call a composite attribute. To represent this in the ER diagram, we create an oval, and all separatable attributes are put on top of the oval, connected by another line. For multi-value attribute, they are an attribute may have a set of values. So sometimes these kind of attributes can have more than one value to be stored in the one attribute. In computer science perspective, if you create one variable, you store one value. However, for these kind of things, you then need to create an array to design for this type of attribute so that you will be able to store all possible values going to be there. And again, this is indicating it may have a set of values. Not necessarily everyone have that. So for example, degree, you can have double major, you can have triple major. So when someone appears in your database, your data need to be able to handle that. Another example is the color of the cars we discussed in our previous video. Some cars can have 2 colors or more. And you will be able to set up a limitation, say that a car can have more than 1 color and probably no more than 3. So you can set up some rules when you design the database. But to handle these kind of things, they have possibly have multiple values to be stored in one attribute. Then that is going to be our multi-value attribute. That requires special treatment in this case. The combination of the 2 is what we call a complex attribute. So a complex attribute is a combination of composite versus plus the multi-value. So a good example is your address. So address itself can be further divided into street, city, state, and zip code, and a person may have multiple addresses that need to be stored. In that case, if your address is treated as a composite attribute and you want to store multiple of the address for the target, it is going to be a complex attribute. The same thing with the phone. If the phone number saying that you can store any kind of phone, so you can have your cell phone, you can have an office phone, you can have your home phone. If you are not separate each one with an individual attribute, and instead you create a complex attribute to hold whatever users want to input for their phone, then it will become a multiple phone numbers and forms a complex attribute. So I hope these slides can clarify any confusions that you may have regarding to the composite, multi-value, as well as the complex attribute. Now let's look into an example to have a little bit more understandings about this. A database usually contains a group of entities that are similar. So for example, a car. An entity type defines a collection of entities that have the same attributes. So if we are looking at car as a target, that a car is our entity. To represent a car entity, you use a rectangular box to indicating this is an entity that I'm looking at. Attribute names are enclosed in ovals and are attached to their entity type by straight lines. Composite attributes are attached to their component attributes by straight lines. Multi-value attributes are represented in a double oval attributes. So this is going to be a good example for you to understand. So think about this. Based on what you have known right now, if you look into this figure, you can understand now we are going to create a database. The database is about a car. So car is one of the entities that I'm interested in. There are several different things I want to keep track of. The registration, it has a composite attribute format indicating registration is composed of state and number. Think about your tag number. Every state have their own design with their own representations of the numbers. So you need to know which state you are looking at so that you can find the cars. If you only have the number without a state, it will give you some difficulties. And therefore, registration is a composite attribute that comes from state plus the number of your tag number. Vehicle ID, VIN number, every car has a VIN number, so that's a thing, and it doesn't make any sense to further divide that into smaller things, and therefore it's neither composite attribute nor multi-value attribute. Year, make, model, they are basic attributes regarding to the cars, and you should all know about that. Color, in another case, like we said earlier, a car may have multiple colors. So now we need to use a double oval to indicating that you can have multiple colors. This database will be able to handle that. So this is the design of the entity for the car. If we look deeper into it, and then seeing that the car is composed of the following attributes: registration, vehicle, ID, make, model, year, and color. So you can see that the color is a special sign over there indicating it can be a multi-value attribute. So you can see if we really look into car number one, it's ABC123 Texas car. The VIN number is like this one, Ford Mustang convertible 2004. You have two colors over here. So this is an example of what the real data would look like. Another car, number two, you can see there's only one color out of it, and therefore that's totally fine. A multi-value attribute is designed there to hold multiple values. However, if you only have a single value, that's totally fine because it's designed to capture all special cases that you may have. One thing that we have not mentioned is what we call a key attribute. So if we go back to the slides, you can see that the one that I put an underline under the registration indicating that is the key attribute that I would use to identify every single car that I stored in the database. Just like your social security number. Your social security number is a perfect key attribute to be underlined using that number to find any one of you. Sometimes you have choices, like the car example. You have two choices. You can use registration, underline that, or you can underline the vehicle ID, VIN number as the key attribute. So in this case, you have multiple choices. The design is based on your choice. For some scenarios, registration for most of us is easier to remember. I wonder how many of you guys remember your vehicle number, VIN number. Most of people don't. I don't. But I do have one student previously be able to name all the numbers of his vehicle number because that is a collectible. He owned the car for a while already, and that's like passed from his father. So in that case, they know about the vehicle number, VIN number. Another example I want to mention over here is this. Say if you are a car dealer, you try to do the maintenance of the cars. Most of you guys will notice that when you drive your car to the car dealer, they scan your barcode for the VIN number because to them, VIN number is more convenient than your registration number. So like I said, these are the choices that you can have. It's hard to say that which one is better than which one. It all depends on the situation. Another good example is in UCA. Okay, whenever you go to registration office or whenever you go to the financial office, what they ask you for the first thing is your student ID. Think about this. Why aren't they ask you about social security number? Because we can use social security number to identify each one of us. But we don't do that because there are some privacy issues about the social security number, so that the schools design a student ID for you and you use the student ID to identify every single one of you. And that is the choices that you can have. And therefore, you need to make your decisions not necessarily in the ER diagram design. You will see some of the ER diagram later that there are two attributes are being underlined. That means there are some choices over there. In terms of the database terminology, we can underline primary key or we can underline all the candidate keys. When we do the implementation, that is when we need to make our decision. In ER diagram, sometimes you can just make the decision, sometimes you can mark out all the possible candidate keys. So important constraint on the entity for entity type is the key on the attributes. An attribute of an entity type for which each entity must have a unique value is what we call a key attribute. A key attribute can be composite. So in our example, the vehicle tag number is the key for the car entity type and is composed of two attributes, and that's totally fine. You need to get your state, you need to get your tag number. Combining the two things then forms your key attribute. An entity may have more than one key, and that is something you can choose to underline, so to specify which one is the choice that you make. So you can see that this is what we have. You can totally underline the vehicle ID with or without this line over there, that all considered as correct. And therefore, when we understand these examples, it is time for us to look back into the examples that we have seen about the company database. Remember that the company database is composed of 4 tables. Each one of them has their requirements descriptions. So their initial design is shown on the following slide. The initial attribute shown derived from the requirement description. And therefore, if we look into the department, think about this. What is the department entity looks like based on the descriptions here? Let's work on this together. Each department has a name. So first of all, because we are talking about departments, we need to draw a rectangular of the department. Then department has a name, a number, and an employee who manages the department. So obviously it has 3 attributes. Name attribute, oval, number, oval, employee who manages the department. So who is the manager? Another oval over there. We keep track of the start date of the department manager. So not only that, we also need to know what time, when did it start about the manager. A department may have several locations. So obviously you can see this is going to be a multi-value attribute. And therefore, for choice number 1, your design can look like this. A department with name, number, manager, manager start date, as well as a multi-value of the locations. Over here, there are 2 choices you can make. You can make name of the department as the key attribute. You can make number of the department become an attribute. So those are the choices you can have. And therefore, you can underline number, you can underline name, or you can underline both of them, indicating they are both candidate keys. To me, number in here has its service. If we are going to choose the name of the department as the key attribute, in fact, we don't need number anyway. Therefore, it is, to my intuitive, better to have the number underlined, indicating that as the attribute. So like I said, this is one of the choice. Some of you may have noticed when you are drawing or when you are designing this one, you will understand manager is the one who manages the department, and we also keep track of the manager start date. So basically, manager start date is associated with the manager. There's a common error number 1 is that instead of you put the manager start date attached to the department, you draw a line connects manager start date to the manager. Try to represent saying that manager start date is associated with manager. I understand the logic behind that, but it's incorrect, because if you draw an attribute to another attribute, that indicating that is a composite attribute. So it cannot be right if you simply draw a line from manager start date to manager. So how do we handle that? We can totally handle that through the other choice by creating a composite attribute that connects the two things together. And therefore, as we discussed earlier, manager plus manager start date equals to manager information. So we basically create additional attribute that try to hold those two things, make sure they are representing the same thing. So this is actually a better choice to represent the information over here. Let's take a look at the next one, projects. Projects is more straightforward. Each department controls a number of projects. By looking into this one, this represents a reverse attribute over here. Project, because we are looking at a project, each description is talking about one entity that we want to work with, and therefore, first of all, we need to draw a rectangular box on the project. To capture this information, we actually need to create attributes, say control department of the project. So we need to create a department or control department attribute to represent this sentence. After that, each project has a unique name, so you need to have another attribute called name, another number, and number again might be a better key attribute to describing the projects. And finally, it has a single location, and therefore it's pretty straightforward. Name, location, number, underline, control department to represent these requirements of the project. The next one is the more complicated one. This is the one that I want you guys to bring out your pen and paper, work on it, try to draw how would you represent an employee information. So work on this one. Try to read the description. We store employee's name, social security number, address, sex, salary, and birth date. So those are the basic, simple, or single attributes that we have. The more interesting thing are here. Try to spend some time, look over it, understanding what is it described, and design the entity for that. Pause the video right now, do this for me, and I will come back when you have a good designs over there. So pause the video right now. Assuming you have doing what I've asked you to do, and let's take a look what's happening over here. As I mentioned earlier, employee will have all the attributes from the name, social security, underline that, address, salary, sex, and birthday. Now let's handle the special things over here. Each employee works for one department. So obviously, by this first sentence, you will have an attribute of the department. Then you will work on several projects. At this moment, it's pretty easy so that you can create a multi-value attribute of the projects, indicating what projects they have been working on. Now, the more complicated part relies on the second sentence. We keep track of number of hours per week that the employee currently work on each project. So not only I need to know what projects they are working on, I also need to know how many hours for each project they have been working on. This is similar to the department example. Not only I need to know who is the manager, but also I need to know when did he start. In here, obviously, we will require to use a complicated, complex attribute method to work on it. Finally, we keep track of the direct supervisor. So this is pretty easy. We have another attribute of who is the supervisor. And therefore, take a look at this one. You will have your name, social security number, sex, salary, address, birthday, supervisor coming from this line, department coming from this sentence over here. And you will have a complex attribute because you need to know which project you work on and how many hours you have been working on. So if you work for one project, you will have one of that. If you're working for 3 projects, you will have 3 sets of works on operation information. And therefore, this is what it looks like for the employee entity. Finally, dependents. Dependents is pretty straightforward. Each employee may have number of dependents, and therefore, because we are looking at a dependents entity, We rectangular box the dependent, indicating who is the belonging employee. And then we also keep track of name, sex, birthday, and relationship to the employee. And therefore, what it will look like is going to be like this way. So now, by looking into the company example, we have all 4 entities. It is the time for us to study in the next video to see how do we connect all of them together to form a company database. One thing I want to emphasize is this. We are looking at a company database. A company database is composed of those 4 entities, and therefore, notice this. There is no entity called company because that's not an entity. A company is composed of these 4 entities over here. So these things connect together represents a company database.